presentation is on resonance lidar studies of the mesospheric sodium at a tropical station. So the outline of my presentation is introduction to the sodium layer system description and its technical details, lidar observations of mesospheric sodium layer, lidar observations of sporadic sodium layer, and finally the outline, summary and conclusions of the sodium. Based on the thermal structure, so in this based on this thermal structure, we have clearly observed the atmosphere can be classified into 4 layers: troposphere, stratosphere, mesosphere, and finally the thermosphere. So the middle atmosphere represents this stratosphere and mesosphere, and all these layers can be different remote sensings can be monitored by 0 to 4 kilometers by LOPI and 0 to 30 to 80 kilometer by okay. Yes. Okay. Not right. Okay. So the different layers can be monitored by troposphere can be 0 to 4 kilometer by LOPI and boundary layers, and 30 to 80 kilometer can be observed by Rayleigh scatter ladder and my scatter ladder, and greater than 80 kilometers is inaccessible to satellites as well as rockets. So that's why this region is very peculiar, and this demonstration very clearly demonstrates about different instruments are probing the atmosphere in different layers. Next. The middle atmosphere in the mesosphere is a region of complex photochemistry and dynamic interactions. So stretching from roughly 50 to 90 kilometer altitude, it is a transition region between the stratosphere and thermosphere. And this is the least understood region of the atmosphere. And it is inaccessible by above 80 kilometer by balloons as well as satellites are unable to access this region. That's why this region is very much particular and a specific interest of this region. And the mesosphere is a chemical characterized by variety of interesting phenomena like sodium metal layers, alkali metal layers, air glow layers, and different metal atoms are being observed. Coming to these all metal layers, the main shooting matures or the genesis for the formation of the alkali metal layers in the region of 80 to 110 kilometer. And whenever as matures enter into the atmosphere, they can ablate and leave their debris in their path. As a part of their debris, it will leave the alkali metal, that is neutral metal atoms are observed. So this region can be mainly, see from here clearly, we'll observe when meteors enter into the atmosphere, this can ablate or burn up simply. It will burn up and debris will be formed in their path. In their part of this debris, we have observed clearly the alkali metal layers. Alkali metal layers such as sodium, potassium, calcium, iron, as well as some few metal atoms also we observed. And this is a typical sodium spectrum. The sodium spectrum dominated by a bright doublet known as sodium D lines, D2 lines. This 588.9 and 589.59. Comparing to this one, this line 589 has twice the intensity of the 589.6. That's why it is having a D2 resonant absorption lines. And metal atoms are useful for the remote sensing is their shiny of their specific resonant wavelengths. Why? Because specific means whenever your laser light can tune into the 589 nanometer, it can resonate and the photons can interact with the atoms, and that atom can resonate and it can produce the backscattered signals. So the D2 group of 589 nanometer has the highest absorption where cross-sectional of thing. And here you can see clearly a laser can enter into the atmosphere. See here, your laser can enter into the atmosphere. It can tune to the 589 nanometer. Here you have sodium atoms will be observed at an altitude of 80 to 110 kilometer. It can be absorbed at sodium atoms and re-emit resonantly. And much of this information have been observed at high and mid latitudes, but less information can be observed at an low latitudes. Particularly, some of the places were observed, like Puerto Rico and some Brazil places only have observed this sodium atoms. But this is the first of its kind observed the sodium lidar data at Gadanki. And here it may be mentioned that there are no sodium lidar data in the Central Asia, particularly I said. In India, this is the first of its lidar data. And coming to the sodium lidar system description and data analysis, the National Atmospheric Research Laboratory, that is NMRF, is the first of its kind to develop and install the sodium lidar there at Gadanki. Previously, it is called as NMRF, and this is the first of its kind of in India. Particularly, the sodium lidar is installed here. And the first sodium lidar observations was observed at January 10, 2005. And this is in sodium lidar typically at National Atmospheric Lidar Gadanki. You see here, yesterday Jayaraman sir had explained about the Rayleigh scattering, Mie scattering and this thing. This sodium lidar is a monostatic configuration. Monostatic configuration means receiver and transmitter will having less than 2 meters or less than 5 meters. That's why it is a monostatic configuration. So one can able to see clearly here, this is an NDR laser. So the pulsed dye laser is pumped by a tunable dye laser, which is operated at a wavelength of 589 nanometer. This sodium, this NDR laser is a 532 nanometer, whose pulse energy is a 200 millijoules of energy, is pumped into the dye laser. This dye laser is a tunable grating system. It is connected to the computer one. This computer enabled one can makes you highly, which enables you rapid transmission of the transmitted of wavelength. So whenever this NDR laser of 532 nanometer enter into this dye laser, this dye laser can tune into the 589 nanometer, whose pulse energy is 25 millijoules of energy. So this 589, the output of this 589 comes into this way. This beam, this sodium, this orange color is a beam which can be expanded by 10 times, and it will be sent into the atmosphere using a steering mirror. This is an inclination of 45 degrees. This sodium lidar can be sent into the atmosphere in this way. So whenever your sodium lidar enter into the atmosphere, I said it can interact with the sodium atoms, which is available at 80 to 110 kilometer region, and it can be resonate itself and can produce the photons. And it can produce the resonate it, and photons will be released. That backscatter signal can be received by an 750 meter Newtonian telescope. This one is a Newtonian 750 millimeter Newtonian telescope, who having a field optics and as well as a interference filter. This one is connected with the PMTs, and these PMTs are used for photon countings, as you are aware that. And these PMTs are fed to the broadband amplifier, which can be amplified, and it connected to the PC based photon counting MCS software. And the photon counting, whose vertical resolution is 300, that is 2 micro, time beam is 2 microseconds, that is 300 meters, and it's a photon counting of 2400 shots. It's in a time resolution of only 120 seconds, that is a 2-minute period. That means it having a vertical resolution of 300 meter and 120 seconds. And this is a typical block diagram of an a sodium lidar system. See here, it's clearly observed that this is a NDR laser. It is fed to this our dye laser, and dye laser is this is in 45 degree steering mirror, and it is in beam expander. From this beam expander, it can goes into the atmosphere. And from the atmosphere, this is that part is a Newtonian telescope, and it is fed to the photomultiplier tube, and this is a broadband amplifier, and it is finally fed to the MCS software that is connected with the computer. This is a typical block diagram of a sodium LiDAR system. And as you are aware that your laser line, there is a sodium LiDAR is enter into the atmosphere, it interacts with the different layers in the atmosphere, like 0 to 30 kilometers Mie scattering and 30 to 80 kilometer Rayleigh scattering. And above 80 kilometer, we have a resonant fluorescent alkali atoms like sodium atoms, but especially our concentration is mainly due to the alkali atoms. And this is a typical photon count profile, which is coming from the photon counts. So one can observe clearly from here 80 to 110 kilometer, we can observe this sodium atoms, sodium scattering atoms, and less than 80, it is an Rayleigh scattering that is due to the air molecules. And this is the formula which can be used for derivation of sodium concentration of concentration of atoms. And this is the flow chart which will be used for finding out the sodium concentration. Just means background signal and extension, and after that we have to range normalization of this one, then a normalization of the signal by Rayleigh scattering. After that we have to add this model, like Syrah model can be added to this one, and finally calculation of the sodium concentration atom, and finally range normalization. Afterwards we can get the extinction of the signal. And after finding this, after deriving this photon counts, one can observe this height profile, height versus altitude. You can see clearly this is a sodium profile having double peaks. So this is an height profile, height altitude versus sodium concentration profile will be observed in this phenomena. And coming to that is the typical installation of an sodium LiDAR at Gadanki. And now we'll move into the LiDAR observations of mesospheric sodium layer. And this is the database which can be used for our observations. So we have an sodium LiDAR observations of January 2005 to December 2006. That is more than 2 years we have used it for the derivation of this mesospheric sodium layer. And this top, and also this sodium LiDAR will be observed only in the nocturnal night. That is the night periods only. That too, the time duration limits for 3 to 11 hours. And we have the top panel represents the number of days observed versus for every month throughout the year. This is 2005, and the second panel is the 2006. And in these two panels, we have observed June and July. We do not have any observations. The main reason is that due to those days are cloudy as well as convective days are dominated. That's why we are unable to find out any observations during this months in 2005. As well as in 2006, we do not have, apart from June, July, we have another 3 months also not available due to the technical problems, due to the system technical problems. That's why we are unable to measure those days also. And the top panel represents the number of days for every month, and the bottom panel represents the number of hours for every month. It is in terms of days, it is in terms of days. And most of the observations will be observed during winter months. Why? Because on those days we have a clear cut sky conditions are there. That's why we are able to observe more number of days during winter season. And this is a typical characteristics of an sodium layer. In this plot, we have different time intervals are observed. The top, that is the first curve A, represents only 2-minute profile. That is our basic profile will comes only for 2400 shots. That is a 2-minute profile. That's why it shows a 2-minute profile. And the second plot represents for 1 hour average, and the third profile represents 4 hours, and the next one throughout the night, and the E represents the 1 month average, and the bottom curve represents for 1 year average. What I want to convey from this figure is, you can see clearly in all these curves, we have observed 2 peaks, primary peak and secondary peak. The primary peak will be observed here. Throughout our period, we have observed this primary peak will be observed at 92 kilometer approximately. And the secondary peak will be observed for up to four curves, and the next this monthly average as well as yearly average also a small sneak is available, a small peak is there. That is the main reason for these peaks is the first peak is mainly due to the photochemistry or mesospheric photochemistry, and the second peak represents the abundance of oxygen is available in the secondary peaks. And this is the typical profile of a nocturnal variation of a sodium layer on particular day. You can see clearly the sodium concentration descends with time. See here, it also observes it is in wave type of representation. So predominant of this plot is the descending of the layer throughout the night we have to observe. This is the 2D curve and this is the contour curve which will be observed throughout the night. And this is the nocturnal variation of a sodium layer, the day-to-day variation of the sodium layer. That means we have to find out how the day-to-day variation will be observed through that one. For that purpose, we have taken in the month of February 5th to 16th, we have a continuous 12 days of period we have observed in this contour. One can observe that clearly, you can see clearly, the sodium will be enhancing gradually from day to day, and particularly in the February 12th, we will observe a large enhancement will be observed. It is the greatest ever throughout the observations. So around 64,000 atoms per centimeter cube will be observed at the February 12th. This is one of the greatest event and one of the most sodium concentrations available in that particular day. February 12th is the most day. So what I want to convey from this one, this may be contributed due to the gravity waves, tides, or the responsible for the variation of day-to-day variations. And this is the seasonal variations of the sodium layer throughout for the entire observation, that is 2005 and 2006. In this figure, we have observed two dominant peaks will be observed in March as well as in October, and the minimum will be observed in August. And one more important thing, we have a gap in this region due to the reason we have a technical glitches on June, July, and August, September, and October in 2006. That's why we have a gap in this seasonal variation. The seasonal variations of the column abundance, centroid, and RMS thickness. Basically, any sodium layer can be characterized by three parameters: column abundance, centroid, and RMS thickness. What is this column abundance? What it represents? This column abundance is nothing but the layer strength of the sodium. How much sodium strength is there? That is how much so number of atoms are available in that particular layer. That is layer strength. And the centroid is nothing but the mean altitude weight. That means the layer thickness can represent the centroid. And RMS thickness is the full width of maximum of a typical sodium layer. These three parameters can identify how your sodium structure can be observed. So in this, this is also a seasonal variations for 2 years, 2005 and 2006 we have observed, and these are the C, and most of the thing, the number of that is the values are observed, the values are not important. What I want to convey from is the sodium concentration will be observed. It should be maximum during March as well as in October and November. And this RMS thickness also having represents this an altitude of 92.5 kilometer, and this RMS thickness is represents the layer thickness. It is around more or less the mean value will comes around 4.5 kilometer throughout the observations we have observed. On an average, we have a layer thickness of 4.5 kilometer we have observed. And this is a nocturnal variations of the abundance, centroid, and RMS thickness. It also see clearly, one can observe clearly here, see, your centroid and RMS thickness having are in phase, whereas your column abundance, that is the layer strength, will be out of phase. So what it means, whenever your centroid is very less, then your abundance should be more, and vice versa. And this can be attributed by the parameters of the sodium layer. Here it can be, this is this down panel can represent the gravity wave phenomena. How that means wave motions also responsible for the sodium layers. It can supplement for this one. And this is then first half an hour and the next last half an hour of a sodium layer for a typical day. What I want to convey is, in this one, you have seen here the bottom top side of this layer can be, for the first hour and the last hour, we have a 2.4 kilometer width, whereas in the bottom side of that one, the diffusion is 2.7 kilometer of the height. So that means your layer is not in constant peak, it varies from one place to the other place. And this is a mean nocturnal variation of the sodium layer. So this is the throughout, it is observation for entire night for 2005 and 2006. Here it starts from 7 o'clock to morning 5 o'clock. The most dominant time, the maximum peak of the sodium will be observed in the early hours of the throughout the variation. That early hours means around 4:30, we have an observations of 8,000 atoms per centimeter cube. Whatever we have observed throughout our 2 years data, what we observed is, in the early hours, we have observed more number of sodium concentration than other timings. Why the more number of sodium data will be observed during the early hours? Still, it is not understood. We are in still progress. Excuse me. Still, we are in the progressing state. How it will be? Why it should be more number of sodium data during early hours? We have to find out. And this is an mean nocturnal variations of the sodium layer parameters. The same thing like column abundance, centroid, as well as the RMS thickness. So here also we can see your whenever your here also the same thing. Centroid and RMS thickness is in phase, and out of phase is your column abundance. That is, whenever your RMS and centroid will be more, then not only your column abundance should be less. And the values are typically represented in the graph. And this is the temporal variation for every 20 minutes. We have given how your sodium layer can be distributed from one end to the other end. That means from time to time, within a minute of 20 minutes, how it will be thing. And this is an yearly average of 2005 as well as 2006. So comparing to this 2005, we have more number of sodium will be observed in 2006. So this 2D graph can explains you the sodium layer having different peaks, like 2 peaks, 3 peaks, like that we have observed throughout the some of the sodium layers we have given in this way. We have observed in all this one, we have observed 2 peaks as well as 3 peaks also available in a different time periods. And these are the some of the conclusions. This is the sodium lidar data used in the study for 2005 and 2006. And mean nocturnal mean profiles of the sodium is a maximum of March and October, and minimum in August. And the column abundance values are like that. And coming to the lidar observations of the sporadic sodium layer, this is the most interesting part in the sodium layers. What is the sporadic sodium layer? How it observed? The sporadic sodium layer, see here, this is an among the various parameters of the sodium layer, this SSL, sporadic sodium layer, can be represented as SSL. So it's an interesting phenomena. What is the sporadic sodium layer means? A dense sodium, a thin enhanced layer can be superposed on a like this, on a normal background layer. See, this is an your sporadic sodium layer superposed on a normal background layer. So this SSL has attracted during this all these researchers. Why? Because it having the characteristics of this SSL having high peak density, large narrow peak width, and full width of maximum is less than 5 kilometers. The SSLs are selected based on this criteria. First one, the maximum strength factor is greater than 2, and the full width of maximum is less than 5 kilometers. We can observe this one. And this is the database used for finding out the SSLs. So in this one, the number of hours is blue color, the number of observations is blue color, and this next orange color represents the number of SSL events. Based on this criteria, we have selected among 169 observations, we have observed 63 SSL events are observed throughout our observations. And we have less number of observations during November and August. Why? Because we have more number of hours of observation, but there is no SSLs are observed. More number of observation, more number of SSLs were observed during December, January, and February. And this figure clearly depicts about how the SSL, that is the sporadic sodium layer, can start and can reach its maximum, and how the decay of the SSL, and finally it should be a normal sodium layer. So the starting from this is your starting of your SSL event, and whenever it reaches to the maximum, it reaches to the 7.4 strength factor. Strength factor means the maximum sodium layer superposed on a normal sodium layer at the same altitude. Let us assume 90 kilometer, how the sodium layer can be observed. The number of atoms will be more. And this is a typical SSL events observed for 2 particular days. The first one will observe on January, and the second one will observe on the February. See here, the SSLs will be observed with respect to the altitude. It changes. It will observe at a 90 kilometer peak, and it is observed at another one. That means SSLs are not fixed to one particular altitude. It varies from time to time and based on that criteria. But the major reason is meteoric ablation is the major reason to find to observe the sporadic sodium layers. And this is the special case which will observe on one particular day. This is also for this clearly observed that the sporadic sodium layer can be observed descend throughout the time. It is descending throughout the time seen. And downwards also it is a 2D profile which having every 20-minute profile we will observe. That means the rising time is more comparing to the decay time. If the rising time we have observed more than 3.5 hours, but decay is only 20 minutes of the time, 20 minutes is there to decay that process. And these are the 2 special cases which were observed by the sporadic sodium layer. One is February 12th. It is the most significant day. Why? Because throughout our observations, it is the major event. February 12th, we have observed more number of sodium, that is more than 64,000 atoms per centimeter cube are observed throughout the observations. And the second one, generally sporadic sodium layers can be observed between the region of 90 to greater than 90 kilometer, but this is a special case which can be observed less than 90 kilometer, that is 87 and 88 or something like that. And this is the thermospheric sporadic sodium layer. Generally mesospheric sodium layers are observed between, I said previously, 90 to 100 kilometer, but the layer of greater than 100 to 110 kilometer, the sporadic sodium layer can be called as thermospheric SSL we can call. So in this day, in this particular day, both thermospheric as well as mesospheric sodium layers will be observed. See here, this is above 100 kilometer we can call as the thermospheric layer, and below on the same day we observe the mesospheric sodium layer also will observe. The important thing is thermospheric thermospheric SSL having 1/10 of the sodium concentration, whereas the mesospheric sodium concentration is more than 10 times. Strength factor is more than 10 times. And a few parameters have given for statistical parameters have given histogram like strength factor, peak width, and how it will be observed. Those things will be observed. This is the strength factor, and this is the time of occurrence. And rise and fall times. This rise and fall times can be observed. That means start of the peak to maximum peak we have considered as a rise, and from middle of the maximum peak density to end of the, that is decay of the SSL, we can consider as a fall. So in this one we have observed more number of rise than the decay. That means the rising time is more than the falling time. And this is the trajectory which can be used for finding how your sporadic sodium layers can be trajected. That means it is in ascending way or descending way. Most of the cases we have observed in the descending mode only, but some of the cases we have observed ascending also, but the domination is descending only. And this is most of the events can be observed within the range of 90 to 98 kilometer, and some event will be only one event will be observed less than 88 kilometer. And this is the histogram which represents the number of observations between 0 to, actually we have divided this one into two modes. The first one is 1 o'clock to 6 o'clock one time period, and from night 7 o'clock to morning 6 o'clock we have divided into two events. One is 33 events and 31 events. In both these cases, when your sporadic sodium layers are occurred more, that is the number of observations are observed in the night time, when it will be fall more time, we have clearly observed that during early hours we have more number of SSL peaks will be observed than the remaining time. And these are the conclusions, and this is the summary. And after that, after 2006, we have a technical problem in the sodium lidar. That's why we have not operating presently. We are still in working mode. The problem is not yet resolved. Once it is available, the sodium data again will be collected from the NARL.
Thank you, Dr. Vishnu Prasanth, for a very clear and illustrative presentation on sodium layers. There are any quick questions from the participants in the room? Prasad.
A very nice presentation, sir. This is the first time I'm seeing that sodium layers in the presentation. But we have an opportunity meteor radar, sir.
Yes.
So as you told that sodium layers mainly formed due to that meteor count. So is there any seen that during that higher meteor sodium layer, at the same time we have seen any meteor counts from meteor radar? Is you noticed it, sir?
Unfortunately, whenever meteor radar is installed at SVU, the lidar sodium lidar observations were not available. Why? Because there is a technical glitch at NARL that is still not yet resolved.
Yes, sir. Okay,
Simultaneously, during mature radar data as well as sodium, but we have an evidence whenever mature showers are there, at the same period we observe the sodium data enhancement also we have observed clearly. That cases also we have.
Present we have that data now.
Yes.
So maybe that February month, whatever you showed now. So current February months, current period, it is same, it is there, meteor counts more.
Yeah, in February only we have observed the largest ever sodium concentration around 64,000 in February month only.
Similarly, meteor counts also, sir? Same.
That mature data is not available
At present.
at present.